In this video, we're just going to finish up the 15.6 stuff that we didn't get a chance to talk about. So I'm going to start with these type y and type x integrals. We already talked about the type z ones in class. So those are the ones that you can set up as z first in a triple integral with just one integral. A type y integral is the ones that we can set up as y first. So we want to be able to do y first here. And so, again, I'm going to do my triple integral. My first innermost integral is going to be that dy integral. And then we can do dx dz or dz dx, depending on which one works for us. As long as one of those two can be done with y first with just one integral, then we call that type y. So when I'm doing that y first integral, I'm moving in the same direction as that y-axis. So my y-axis in 3D moves left to right. So I'm thinking about that left side for the y and the right side for the y. And my innermost integrals in 3D and for triple integrals are going to be those surfaces. So I noticed that on that left-hand side, I'm seeing this blue surface, which we've called y1 of x. So that's y1 of x. Sorry, y1 of x and z. It's allowed to have both x and z in there as its variables. And then I move left to right. On the right-hand side, I'm seeing that purple surface. And so let's go ahead and look at this purple surface here. I'm seeing that purple surface, that y2 of x and z. And so x and z, y2 of x and z, that's going to be my inner bounds. And then after I do that, after I get those inner bounds, I'm going to just get rid of my y. I've already done y. So I'm just looking at x, z. We're going to smush this around away, kind of see what the projection looks like in that xz plane. So I'm taking sort of the biggest shadow in that xz plane. And so I'm seeing something that looks like this. And so I'm just going to call that region D. And we would set up that integral in terms of either xz or zx, maybe one or the other, depending on what we're going to do. So that's my y first, my type y. If I'm doing type x, then I'm going to have that x be the innermost integral. So this is going to be my x first integral. And so again, I can either do yz after or zy. Either one of those is going to work. Now I'm going to move in the direction of that x-axis. So my x-axis goes back to front. That first surface I'm hitting is this purple surface. X equals some x1 of y and z. x1 of y and z. I move into my surface. So that's the back there. I'm moving forward. And I'm leaving along that green surface. And that green surface is x2 of y and z. x2 of y and z. Again, after I do my x, I'm getting rid of the x. So I'm going to just be left with y and z. I'm pushing everything back into that yz plane. And so I should just see this little rectangle, basically that green surface there, collapses onto that rectangle when I get rid of my x's. I'm going to again just call that region D. It's a different D than the previous example. And I'm going to do that double integral over that region D. So depending on which ones we do as our inside integral, if I do x as my inside and I can set it up as one integral, it's type x. If I do y as my integral and I can set it up as one integral, it's type y. And we saw before, if you just do z and you can set it up as one integral, that's going to be type z. All right, we'll do some more examples, and we'll see one example where we can set it up in the 6 different ways. But let's do one other example before that. Okay, in this example, we want to look at this region and see which type of region it is. And so we want to know, again, if it's type X, type Y, or type Z. And then we'll talk about how to actually set it up in those different ways, just so we can get some practice. And so it's the region in the first octant. So I know X, Y, and Z are all positive, bounded by Y equals 0, Y equals 1, Z equals 1, and then x plus y equals 2. So let's go ahead and sketch each of those out. Y equals 0. That's going to be my xz plane. So that's the plane over here. Y equals 1. I'm going to go out to 1. I'm going to have sort of some similar wall here. I'm drawing them sort of as triangles because it's easier to picture. And then we'll sort of fill in as much as we need to later. Maybe I'll draw that one kind of straight out. Then I have z equals 1. So there's sort of this top here at z equals 1. So far, I have sort of a box. I've got my two walls, the blue wall on the left, the purple wall on the right. They're going all the way up. And then I've got that green ceiling. But I don't know how far this is coming out towards me. So the last thing we have is that x plus y equals 2. I'm going to draw that in the xy plane, so in z equals 0 first. It's just going to be a line that has intercepts of 2. So I'm going to go out a little bit further there. Let me just draw my axes a little bit further out. So I have 2 and 2. And so my x-intercept and my y-intercept are both 2. And so what we're going to see here is this plane is going to go straight up. I'm going to pull this green plane all the way out, the top ceiling. Oops. And I'm going to pull that pink one all the way up. So I'm going to draw straight up here. And we can start to see what I'm seeing here is this green surface is going to be shaped something like this. I've got the green ceiling. And then I have this pink line, this purple line. They run into each other somewhere. I'm just going to highlight that in black. And then I have that green ceiling. So it's kind of hard to picture. I'm going to go ahead and draw the projection in the XY plane because that might be easier to picture exactly what's going on. So in the XY plane, I'm just seeing this line, x plus y equals 2. So that's at 2 and 2. And then I'm seeing the line y equals 1. Oops, I did x equals 1 instead of y equals 1. Let's fix it. Y equals 1. And then I also have my y equals 0. And so the region that I'm looking at is this region in between here. Let's see if we can highlight that out so we can see it better. So I'm looking at this region here, but that comes up to a z value height of 1. So I'm seeing that downstairs there. It comes up, is also upstairs at a height of 1, and I'm getting everything in between those two. So that is the region that I'm trying to integrate. And I'll put a link below this video in Husky CT that shows what this looks like in GeoGebra 2. So now we need to think about, is it type X, type Y, or type Z? So let's do type X first. We'll just do alphabetical. Type X question mark. When I'm doing type X, I want to think about moving in the direction of the x-axis. So the x-axis is the one that's coming out here, back to front. So in my 3D picture, in the back, I'm seeing that back wall back there. And in the front, I'm seeing this pink wall here. And it's always going that back wall to the pink wall. If I just look in my 2D picture, I'm seeing, right, move in the direction of the x-axis. That was not a very helpful. Moving in the direction of that x-axis, I'm starting at that back wall, which I put in blue now. And I'm going in and I'm leaving in the pink wall. Sometimes this 2D picture can help us. And in this case, we just know the z is just that height of 1. So it's not going to mess us up at all. So I can integrate for type X from that back wall. So that's the blue wall. That's there at x equals 0. Because I know it's in the first octant. All the way out to the pink one. That pink equation is x plus y equals 2, or x equals 2 minus y. 2 minus y. And so then we can do that. Afterwards, we would have to do dy dz or dz dy. So dy dz or dz dy. And let's go ahead and draw what that's going to look like. I'm going to push this figure back. I get rid of the y's. And so I'm just seeing, sorry, get rid of the x's because I did x already. So I'm just looking in y, z. If I get rid of the x's, if I smush it back, I'm going to see that blue rectangle along the back wall. And then that pink surface sort of flattens into that blue rectangle. And again, if you look at this in GeoGebra, you should be able to see that pretty easily. That's going to be at 1 and 1. So we can easily see if I do dy dz or dz dy, both of those bounds are going to be just 1 and 1. And so this is type X. If I do type Y, I'm thinking about splitting it up now, setting it up in a y first integral. So I'm moving in the direction of the y-axis, left to right. Remember, this is my y-axis. I've got a 2 labeled there, which kind of looks like a z. That was sort of hard to see, but this is my y-axis. And so if I look on the one side of the y-axis, I'm seeing that side wall. But on the other side on the y-axis, I'm seeing both this purple wall and this pink wall. It's sort of easier to see if I look at my picture in 2D. So if I look downstairs at this picture down here in 2D, if I move in the direction of the y-axis, on the bottom is always that blue wall. But sometimes in the top, I stop at purple, and other times I start at pink. And so this is, no matter which one you do next, we'd say no. This is not type Y, because I can't set it up as Y first, because I'm going to always start at 0, but sometimes I need to do 1, or sometimes I need to do the Y equals 2 minus X, and so I'd have to do 2 separate integrals to do that. So I can't do it as type Y. For type Z, I'm moving in the direction now of the Z-axis, bottom to top. So on the bottom, I'm always seeing that gray floor. So the bottom, I'm seeing this gray floor down here. And the top, I'm just seeing this green ceiling. And so for my Z first integral, on the bottom, I'm seeing that 0. And on the top, I'm seeing 1. Put that in green here. And so that is just one bottom, one floor, and one ceiling. And so I can do that. So we can say yes. And let's just check then what we would do next. If I'm looking at my projection then into X, Y, that's this picture I've already drawn. That's when we get rid of the Z's. And so I'm seeing this picture here. And we already said for this picture, we can't set it up as Y first, because sometimes there's purple on the top and sometimes there's pink. And so I would have to do X next and then Y. So I can set it up as Z first, but I have to be a little bit careful about what comes next. And so if I do X next, I'm going to go from X equals 0, that's just that starting point, to X equals that pink, which we said was X equals 2 minus Y. And then if I get rid of my X's and look at biggest and smallest Y's, I go from 0 to 1. And so I can do a type X and a type Z, but I can't do a type Y because we have those 2 different walls in the Y direction. Okay, take a second, look back over that, make sure that makes sense to you, and I'm happy to answer any questions you have. So again, we said for type X, you could set it up in either of those 2 ways. Type Y, we can't set it up with one integral. We could do it if we did it as the sum of 2 different ones. And then for type Z, I can only set it up as 1 for X, Y. If I tried to do Y, X, I would also need 2. But because there was 1 that was possible, I would call that type Z. Okay, so we started this example in class. I'm going to go ahead and just pick up where we left off. There's a separate video that runs through the entire example start to finish. So if you didn't see that in class or you don't remember what we did from class, you might want to watch that other video instead. So we have this region E, and it corresponds with this integral that was given. And so we took that, we said z went from 0 to 1 minus y, and y went from root x to 1. And so we were able to draw this surface. I'm going to go ahead and just kind of highlight some of the things so I can talk about them. I've got this blue piece of the wall there. It's kind of curved. That came from that y equals square root of x. And I'm just going to solve it for x equals as well. X equals y squared. So I have that blue piece of the wall. And then I have this green piece up here. I'm going to have a slightly different, let me make it a darker green so we can kind of use the same similar colors that we've seen before. Give me a second to do that. So again, if you need to pull up that GeoGebra, there's a link there next to the video. Or you can see the link down here at the bottom of the screen if you just type that in. So I've got this green wall. I didn't do a very good job of making it a darker green. There we go. Okay. This green sort of ceiling, like diagonal guy. We've got the purple curve of intersection between the two. We've solved for a lot of those. So the green guy was z equals 1 minus y. And then that purple curve of intersection, that's just that curve. And it was square root of x equals 1 minus z, or z equals 1 minus root x, or x equals quantity 1 minus z squared. And then we have some zeros. So there's the floor. I'll make that pink. I'll call that the floor. That's z equals 0. And then there's the back wall. I'll make that just sort of gray. It's kind of hard to see, but I'll call that the back wall. And that's where x equals 0. Okay, so that's my 3D picture. And the floor is z equals 0. That back wall is x equals 0. I've got the green diagonal slanted part. That's kind of like a ceiling that's coming down to the floor. And then I have that purple wall, sorry, that green wall, colors are hard, blue wall that goes straight up. And the blue wall that goes straight up and that green diagonal wall intersected the purple curve. Okay, that's the 3D picture. And so we've got that. We've got all of our projections into those 2D planes. And so what I'm going to do is I'm actually going to just kind of copy this. Let's see how we can do here. I'm going to take this whole picture and I'm going to copy it onto the next slide, and then we'll start doing some integrals. Okay, so this is just what we had before. And now I'm going to do type X on this screen. So I'm going to do, let me go ahead and get my integrals all set up. We'll do dx first, and then we do y, and then z, or z, and then y. So I'm moving in the direction of the x-axis. Say what I'm thinking here. Move in the direction of the x-axis, back to front. And so when I'm moving back to front here in the direction of that x-axis, I'm going this way. The first thing I hit is that back wall. And so I'm going to go from that back wall. I'll label that back wall. I go into my surface. I can't hit the green because that doesn't have any X's in it. So I'm going to leave along that blue wall. I leave along the blue wall. And so if I actually plug in those values, the back wall is x equals 0. And the blue wall was x equals y squared. So I go from 0 to y squared with respect to x. After I do my x's, now I need to think about what's happening in the yz plane. And so I'm looking at this picture here. I don't care about those other pictures for now. I'm just thinking about that yz plane. If I move in the direction of the y-axis next, left to right, I first hit y equals 0, and then y equals 1 minus z. And then z is just points 0 to 1. Or if I do z first, I move in the direction of the z-axis, bottom to top. So that's 0 to 1 minus y. And then y goes from 0 to 1. And so we'll pop the function in there, whatever function they give us. If I do out those integrals, those will both give me the same thing as my two different type x integrals. On the next slide, we'll do the type y's. Okay, so let's do our type y's here. So I'm going to do my y first integrals. And then after that, I'll do xz or zx. For the innermost integral, that's my surfaces. I've got to look at my 3D picture. I'm moving in the direction of the y-axis, so that y-axis moves left to right. So I'm going to move left to right and think about which surfaces I'm hitting. So I hit that blue surface first. I'm going in along that blue surface, so that's the blue wall on my left. And then I go into the surface, and I'm leaving along that green sort of tilted wall. I'm doing type y, so I need all of my equations to be in terms of y equals. So for this blue wall, the y equals is square root of x. So I've got a square root of x on the bottom of my integral. And then for the green one, that's z equals 1 minus y. And so it's y equals 1 minus z. And so I go to 1 minus z up there. I'm just going to get rid of where it says green so it's kind of more clear what we're putting up there. So that's my 1 minus z. So it doesn't matter what's coming next, right? I didn't care if it was x next or z next. I just looked at the equations, and I'm allowed to have both x and z in my equations, which I do here. One of them has an x in it, one of them has a z in it. They could both have both variables if you need to, but they're the same as each other, f and f. And now I need to do just that xz integral. So I'm looking at my xz picture. That's the kind of complicated picture we talked about. I don't care about those other two pictures for this one. For my xz picture, if I do x first, moving in the direction of that x-axis, left to right, I start at 0, and I end at that curve, which we found out was 1 minus z quantity squared. And then z is just points, so that's 0 to 1. Point up there is 1. If I do z first, I'm moving bottom to top, the direction of that z-axis. So that's from 0 to that purple curve, which in terms of z equals is 1 minus square root of x. And then x is just points, which is 0 and 1. So again, once we have those pictures all done, then we can kind of look at those and read off the curves. So those are going to be my type y's. And finally here, let's do our type z's. And so I want to do my z first integrals. After we do z, we can either do yx or xy. And so if I do z first, I want to move in the direction of the z-axis, bottom to top. So my z-axis is going bottom to top like this. So I see the floor down there on the bottom. And then as I go up, I'm going to leave along that green surface. So I'm going to go from the floor, which is z equals 0, to that green surface, which is z equals 1 minus y. So again, it doesn't matter what letters come next. I'm just thinking about z. I'm looking at my surfaces. I see z equals 0 on the bottom, and on the top, I see that z equals 1 minus y. That blue surface doesn't have any z's in it. It's straight up and down for z, so I can't hit that when I'm moving parallel to that z-axis. After I do that, I need to do I need to do yx or xy. And so I'm just looking at my xy picture. I don't care about these other pictures. If I do y first, I'm moving in the direction of the y-axis, bottom to top. So I see that blue one on the bottom, which is y equals square root of x. I see the green one on the top, which is y equals 1. And then x goes from 0 to 1 in terms of points. 0 and 1. If I do x first, moving left to right, I go from 0 to the blue. So 0 to the blue in terms of x equals is x equals y squared. And then y in terms of constants in terms of points is just 0 and 1. So we get all of those. One of these, I believe this is the one that we started with. So we can double check that we got the same thing that we started with. That's a good way to check. But otherwise, we have all of the different pieces now. Hope this was helpful. Again, there's another video that goes through the whole thing if you wanted to see where we got those projection pictures, or if you just want to see me explaining it a different way. Make sure you check out that GeoGebra link so that you can see that picture in 3D to kind of help you get a feel for it.